In the networking code, you may have noticed that there are different types of exceptions, but you didn't know what they're for. Now, we haven't formally talked about them, so let's do that now. The first time you saw an exception was in the first course in the Nano degree when we were building the Just Java coffee ordering app. Now, the app ran into exception and crashed. To debug the program, we opened up the Android logs to reveal the stack trace, and then discovered an illegal state exception was thrown when the submit order method could not be found in the main activity. All right, let's look at some documentation about exceptions. When a Java method fails or runs into an unexpected state, it can throw an exception, short for an exceptional event. Exceptions are basically errors, but they're also captured or wrapped in actual instances of the exception class, which holds information about what went wrong and what was happening in the system at the time. If you look here on the left, for example, you'll also notice that there are more specific types of exceptions that actually extend from the exception superclass, a great example of inheritance in use in the Java framework. In other words, all of these specific classes are subclasses of the base class exception. For example, here we have an illegal state exception or a null pointer exception. We also saw the security exception earlier in this lesson when the internet permission was missing from our Tsunami app. Now, you could create a new exception class for your own purposes. For example, we could create an invalid earthquake exception and define it as we normally would, create a custom class, and then have that custom class just extend from the base exception class. From there, we could customize the exception to hold, say, very specific information about an invalid earthquake scenario. So as a developer, you can write a method that declares that it will throw an exception, meaning that the code inside that method either 1, generates an exception to indicate a unique condition, or 2, and more commonly, calls a method that throws an exception, meaning that the Android runtime tried to execute some code but ran into a problem and therefore gave notice of the problem by throwing the exception. It's also important to note that if an exception is thrown, it also means that the code following the line that caused the exception won't get executed. So how do you do this in Java code? There are two distinctions that I'd like you to pay attention to. Number one, anywhere in your Java code where you want to cause or invoke an exception, you use the keyword throw, like in this example here, where we want to throw an invalid purchase exception because we detected that something went wrong within our complete purchase method. Number two, and this is much more subtle, anytime our code throws an exception that isn't a descendant of the error or runtime exception classes, we must explicitly declare in our method's signature that our method could throw such an exception. In Java programming speak, this is known as a checked exception and has the implication that any code that calls or uses our method must handle the exception, i.e. call our method in a try block. This is enforced by the Java compiler. In other words, whoever calls the complete purchase method has to have a backup plan if the invalid purchase exception is thrown or occurs. We'll talk about how to handle exceptions in the next video. In case you'd like to learn more about unchecked versus checked exceptions in more detail, see the tutorial linked in the notes below this video. One more important note. Just because there's a standard framework for how to use exceptions in Java, it doesn't mean that you should throw exceptions every time something goes wrong. This is where developer discretion comes into play. Ideally, if we discover a problem or a unique situation, we should try and handle it gracefully in code by just falling back to some reasonable default behavior, for example, and continuing executing if possible. We call this failing silently. However, should we deem that it be more detrimental to keep going with an error state, then we may decide it's best to notify our calling code of the error by throwing an exception. We've seen this in play already. In the case of our Tsunami app, when we tried to request earthquake data from the internet, the Android framework code threw a security exception. This is a case when it's better to throw an exception and crash the app as opposed to continuing without the internet permission. Now, if the Android framework code had failed silently, then we as developers would probably be super confused as to why we didn't receive a response from the server. In the case of the Tsunami and Quake Report apps, we won't actually be creating our own custom exceptions or throwing exceptions intentionally. We will, however, be calling the Android framework code that does throw exceptions, and we'll need to handle those exceptions appropriately. Let's talk about that next.